Today we are going to be looking at equilibrium of a particle in 3D and determine the unknown forces. Equilibrium of a particle in 3D. In three-dimensional space, a particle is in equilibrium when the vector sum of all the forces acting on it is zero. This means the particle does not experience any net force, resulting in no acceleration, according to Newton's first law of motion. To determine the unknown forces acting on a particle in 3D equilibrium, we will apply the principles of static equilibrium, which require that the sum of the forces in the x direction must be zero, the sum of the forces in the y direction must be zero, the sum of the forces in the z direction must be zero. Equilibrium conditions in 3D. For a particle to be in equilibrium in 3D space, the following conditions must hold. Number 1, summation fx, which should be equal to 0, which means sum of forces in the x direction is 0. Number 2, summation fy, which should be equal to 0, which means sum of forces in the y direction is 0. Number 3, summation fz is equal to 0, which means sum of forces in the z direction is 0. If there are multiple forces acting on the particle, each force can be represented as a vector with components in the x, y and z directions. Let's break down how to determine the unknown forces. Step 1. Define the forces acting on the particle. Let's assume we have multiple forces acting on a particle. Each force can be described by its vector components in 3D. Step 2. Set up equilibrium equations. For each force, we can write its components in the x, y and z directions. Now we write the equilibrium conditions for each direction. Step 3. Solve for the unknown forces. If there are unknown forces, say Fx, Fy, Fz acting in the x, y and z directions, we can substitute the known forces into the equations and solve for the unknowns. For example, if we know that F1 is equal to Fx, Fy, Fz, we can solve the equilibrium equations as follows. In the x direction, Fx plus other forces in x is equal to 0. In the y direction, Fy plus other forces in y is equal to 0. In the z direction, Fz plus other forces in z is equal to 0. By solving these three equations, we can find the unknown components of the force vector. Now, let's take a look at this with the help of a problem. A horizontal circular plate weighing 60 pounds is suspended as shown from three wires that are attached to a support at D and form 30-degree angles with the vertical. Determine the tension in each wire. Solution. Tension forces. The tension in each wire has both a vertical and a horizontal component. According to the equilibrium of particle, summation Fx, Fy and Fz are equal to 0, where equation of x component is tension of AD is in negative direction, so it's negative into sine 30 into sine 50 plus tension of BD into sine 30 into cos 40 plus tension of CD into sine 30 into cos 60 is equal to 0. Similarly, y component is minus tension AD into cos 30 minus tension BD into cos 30 minus tension CD into cos 30 plus 60 pounds, which is equal to 0. Similarly, z component will also have the same. Solving equations 1, 2 and 3, we get tension AD is 29.5 pounds, tension BD is 10.25 pounds and tension CD is 29.5 pounds. So we come to the conclusion that to determine the unknown forces acting on a particle in 3D equilibrium, we must apply the conditions of equilibrium. That is, the sum of forces in each direction must be 0. By setting up the equilibrium equations for the x, y and z components,